AI is running out of power. Not data, not talent, electricity and cooling. And that's why some of the world's biggest technology companies are now seriously asking a question that sounds like science fiction. What if the future of AI computing isn't on Earth at all, but in space? In this video, we'll examine where this idea really comes from, who is actually discussing it, what problems it's meant to solve, and whether orbital AI data centers are fantasy, or a realistic part of the future. No hype, no speculation, just the reality behind one of the most extreme ideas in modern technology. Modern artificial intelligence runs on computation, and computation runs on energy. Training today's largest AI models consumes millions of kilowatt hours, and once those models are deployed, the energy demand never stops. Every prompt, image, video, or AI-generated decision requires continuous inference at massive scale. Data centers are already among the largest electricity consumers in the world. AI is accelerating that demand faster than power grids, regulators, and infrastructure expansion can handle. In some regions, new data centers are being delayed or rejected entirely, not because of cost, but because the local grid simply cannot supply enough power. For the first time, AI progress is being constrained not by software, but by physics. Electricity is only half the problem. Every unit of energy consumed by a data center becomes heat. As AI chips become denser and more powerful, removing that heat becomes one of the hardest engineering challenges in computing. Many large data centers rely on enormous cooling systems that consume vast amounts of water. Some facilities use millions of liters per day just to stay operational. This creates environmental pressure, political resistance, and long-term sustainability concerns, especially as AI usage expands globally. As cooling and energy costs rise, the question becomes unavoidable. What if the environment itself could do some of the work? From a purely technical perspective, space offers several properties Earth increasingly struggles to provide. First, continuous solar energy. In orbit, solar panels receive constant sunlight without night cycles or weather interruptions. Second, extreme cold. While heat management in space is complex, the absence of atmosphere allows for efficient thermal radiation if engineered correctly. Third, freedom from terrestrial constraints. No local grids, no land use conflicts, no competition with residential or industrial electricity demand. This does not make space easy, but it makes it interesting. The idea is no longer, can we do this? It's, at what point do Earth-based solutions stop scaling? This idea is not coming from science fiction or internet speculation. It is emerging quietly from the same organizations already building and operating the world's AI infrastructure. To be clear, no major company has announced an operational AI data center in orbit, but several of the most powerful technology and aerospace leaders have openly acknowledged that AI growth is becoming energy and infrastructure constrained. Elon Musk has repeatedly warned that AI progress is now limited by power generation and compute availability, not intelligence. SpaceX's role is not about data centers directly, but about dramatically lowering the cost of access to space, a prerequisite for any future orbital infrastructure. While Musk has not announced space-based AI facilities, his public statements frame space as a long-term extension of human industry once Earth reaches physical limits. Jeff Bezos has consistently argued that heavy industry should eventually move off Earth to preserve the planet. Amazon Web Services already operate some of the largest AI data centers in existence. At the same time, Amazon is investing heavily in space infrastructure through Project Kuiper, which aims to deploy thousands of satellites. Bezos has explicitly described space as a future home for energy-intensive infrastructure, even if AI compute is not the first application. Microsoft is one of the largest buyers of AI compute in the world. Satya Nadella has publicly emphasized that AI expansion is increasingly limited by power, cooling, and data center capacity, not by model innovation. Microsoft's experiments with unconventional infrastructure, including underwater data centers, signal a willingness to explore non-traditional environments. Space fits within that same strategic mindset. Google operates globally distributed AI infrastructure and invests heavily in renewable energy. Company leadership has acknowledged that future AI systems will require new infrastructure models, including advanced cooling, alternative power sources, and long-term sustainability planning. While Google has not committed to space-based compute, Its research direction aligns with the same fundamental concern. Earth-based scaling has limits. Perhaps the strongest interest comes from governments. Defence and space agencies have studied orbital computing platforms for resilience, security, and autonomy. The appeal is not speed, but survivability. An orbital compute platform is harder to disrupt, harder to attack, and less dependent on terrestrial infrastructure, making it strategically valuable even at high cost. Despite the interest, the obstacles are severe. Launching thousands of tons of computing hardware into orbit remains extremely expensive. Maintenance is difficult, slow, and risky. Radiation degrades electronics over time, requiring heavy shielding or redundancy. Latency also matters. For many AI applications, even small delays are unacceptable, and orbital systems introduce unavoidable signal lag. These are not minor challenges. They are fundamental constraints that prevent space-based AI from replacing Earth-based data centers anytime soon. The realistic future is not Earth versus space. It is Earth and space working together. Orbital platforms could handle energy-intensive batch processing, long-term model training, backup and redundancy, strategic or isolated workloads. Earth-based data centers would continue handling low-latency services, consumer applications, real-time AI systems. This is how infrastructure has always evolved, by adding layers, not replacing foundations. 10 years ago, this conversation barely existed. Today, it does because three trends have converged. AI models are scaling faster than expected. Energy constraints are becoming visible bottlenecks, and access to space is cheaper and more reliable than ever before. When technology reaches physical limits, it doesn't slow down. It searches for new environments. In the short term, AI data centers in space are impractical. In the long term, they are no longer absurd. They represent a rational response to energy scarcity, geopolitical risk, and the relentless demand for computation. The real question is not whether off-planet computing will exist, but when, for what purpose, and who will control it. Artificial intelligence is pushing humanity toward the physical limits of our planet. And when technology reaches those limits, it doesn't stop. It expands outward. Space may not be the next step, but it is no longer unthinkable. If you want more clear, grounded analysis on how AI is reshaping infrastructure and the future, subscribe, and I'll see you in the next video.